Now that I'm at work, hopefully my tablet and laptop will communicate a little bit better and we can get through this with better handwriting and a little bit more efficiently. All right, taking a look at example 3. The only difference between this one and the first couple is that now we also have an initial point that we're going to be verifying. So we're going to start with that. All we're going to do is sub in the x value for x into the y equation. Notice it says y of pi over 2. It's not a derivative. And we're going to sub 1 in for y. So we're going to replace y with 1, e to the negative cosine of pi over 2. And then we just have to show that it's true. So cosine of pi over 2 gives us 0. So we don't need that negative sign anymore. 0 is just 0, and e to the 0 is 1. So we verified that that initial point is true, and now we'll go ahead and do what we've been doing and verify our differential equation as well. This one, we have y prime, or the derivative, is equal to y times the sine of x. So we'll start by taking the derivative of our function. The derivative of an exponential is the exponential, so we're going to take e to the negative cosine of x times the derivative of the exponent. Now the derivative of cosine is negative sine, so the derivative of negative cosine would be positive sine. Nothing to simplify here, so now we're just going to sub that into our differential equation. So we're going to set y prime, what we just got, e to the negative cosine of x times sine of x equal to y, so we're going to sub in that original function, e to the negative cosine of x times sine of x. And there's really nothing else for us to do. We just proved that that differential equation is true. On this one, another step up. This time we have to solve for c. We're given an initial condition, that 3, 4, and we're given the solution. So all we have to do is sub those values in for x and y to solve for c. So that's going to be my first step. Replacing x with 3 and replacing y with 4. We're going to simplify and solve for c. And because there's really no solving here, you would punch that in your calculator. I got 2 for c. All right, this is one where I am going to change to the dy dx notation. We've got y times y prime. I just think that's too confusing and too easy to mess up. So as I take the derivative on this one, I'm going to use the dy dx notation. Derivative of 2x squared is 4x. Derivative of y squared is 2y, chain rule, dy dx. And the derivative of c, which was 2, is 0. We do have to solve this one for dy dx in order to sub that into our differential equation. So I'm going to go ahead and subtract 4x from both sides. And then divide both sides by negative 2y. Well, the negative signs will cancel. 4 divided by 2 is 2. We have x in the numerator and y in the denominator. Subbing that into our differential equation, we have y times our derivative, the 2x over y, minus 2x equals 0. Y's cancel, leaving us with 2x minus 2x, which of course is 0. All right, this last one is a little bit of review. Instead of verifying all of these differential equations, we're just asked to find it. So we start by separating those variables. I'm going to multiply both sides by that dx. Integrating both sides. The integral of dy is y. We're going to put the plus c on the side with x, so we don't have to put plus c on both sides. Now, some of you might be able to number sense your way through this one. For those of you that don't see it, I am going to let u equal x squared. That input for the cosine, because I see the derivative, sort of, for the most part, in that x, which is out front. The derivative of x squared gives us that 2x dx. And I can just multiply by that 1/2 to take care of the coefficient. All right, so I'm going to pull that 1/2 out front. The x dx gets replaced with du. And now I have cosine of u instead of the x squared. So I can integrate this. The integral of cosine is positive sine. Don't forget that constant of integration. And then subbing x squared back in for u. All right, so this lesson, a lot of it was prior knowledge, just kind of using it in a different way. If you have any questions, please reach out to me.